So hello friends, today we will be solving this interesting question, and I will be covering each and every concept that is very useful for solving this question, and also that concept would be useful for solving any related type of question. So without any wasting time, let's begin. So what the question says, uniform solid cylinder of radius r equal to 15 centimeter rolls over a horizontal plane passing into an inclined plane forming an angle alpha equal to 30 degree with the horizontal. Find the maximum value of velocity v naught which still permits the cylinder to roll onto the inclined plane section without a jump. The sliding is assumed to be absent. Okay, so first important thing is sliding is assumed to be absent, right? So it would be performing pure rolling type of motion, and at each point its velocity, that is vcm, would be equal to uh, omega naught into r, right? Yes. Okay, so this is the given condition to us, and what we have to find, the critical velocity v naught by which it should be rolling on the horizontal surface so that it don't jumps off the horizontal surface on the inclined plane, right? So let's think about that. When will the condition arrive that it will be jumping off the horizontal surface? So when it will be jumping, that means it will leave the touch from the ground, and it will leave the touch from the ground. That means that the normal would be zero, right? Normal applying on the solid cylinder would be zero from the ground, right? So what we can say, if it was jumping, if it jumps, then normal equal to zero, right? Normal applied by the ground on the solid cylinder would be equal to zero. So we have to ensure that normal should not be zero, so that it don't jumps off the surface, right? Okay, so if it was rolling on a horizontal surface, then the normal was not zero, obviously, but normal might be zero when it is changing its surface from the horizontal to inclined. So normal might become zero here at this point, right? So we have to ensure that normal is not zero at this point. Let me name it as a. Normal is not zero at a, right? Okay, so what we have to find is critical velocity, right? We have to find the velocity, maximum velocity, by which we can roll the horizontal cylinder so that it does not leave the ground and don't jumps. Okay, and right. So assume if the cylinder is given a very large velocity, then what will happen is the cylinder comes here rolling, then it will simply leave the ground at this point, and it would jump somewhere here, and again after this it will continue its motion, whatever it might be. Okay, but if it is not leaving the ground, then it will slowly change its direction of motion from this to this, right? Which is parallel to the inclined plane. Its direction of motion will become parallel to the inclined plane, slowly, and during this motion of becoming parallel to the inclined plane, the center of the solid cylinder, let's assume it was here initially, it will it would be here, right? Up just above this point, it would be here. It would perform a circular motion about this point, and it would come somewhere here, right? So we have to analyze the path between these 2 points. Let's name it point B and C. We have to analyze the path of this center of mass between B and C, and yeah, and also we have to find the maximum velocity, right? So assume to find the maximum velocity, what we can see is that for let's assume the cylinder was rolling with a very slow speed. Let's assume very slow speed like 0.001 meter per second. Then you can easily see that it will perform, its center will go from B to C while performing a circular motion about A, and the normal won't be zero at any point if it is very slow speed, and it is I am assuming that it is moving at infinitesimal speed, a slow speed, right? So it will perform a pure circular motion about point A and continue its motion from point C until further on this inclined plane, right? What we have seen, for a very small speed, it is performing a pure circular motion and normal is not zero at any point. For a very high speed, it would leave the normal as soon as it reaches point B. For a very high speed, let's say for infinite speed, then it will leave the normal at point B, right? So there must be a velocity between these two velocities such that it leaves the inclined plane or the ground at the point C. What it means? Okay, now let's see what it means to leave the ground at point C. Actually, it means nothing. If a ball is leaving ground at point C, then it is not leaving the ground. Actually, it is just, we are talking about an edge case, that it would leave the ground at point C. But if it will leave the ground at point C, then it will go like this and come here only, like, right? So it is technically not leaving the ground. So this is the edge case that what we're looking for is that the ball should be leaving the ground at point C, right? So yeah, now we can infer that normal at point C would be equal to 0. Till now it is clear, right? So the entire problem is about this, that we have to make the normal equal to 0 at point C. Okay, so now how to proceed? Okay, right. So what we can do is, or if you are facing any problem, then you can also see it mathematically. Like for at any point, let's say its center was this point A, this is point B, and its center was somewhere at point D, right? At an angle of let's say theta. This angle is theta, or it can be taken as theta. Anything, I am taking this as theta. Okay, so at this point, and let's say its velocity was something v dash. So what would be the equation about along its center? Its centripetal force mv dash square by r equal to the normal that is applied from the ground towards the center. Let's assume it's n, and the gravitational force that is acting away from the center, right? So it is equal to mg cos theta, right? Cos theta minus normal, right? So as you can see, if we are increasing the normal, or we can see it in this way, if we are increasing the velocity, it means that the normal is decreasing, right? And if we are decreasing the velocity, it means normal is increasing. So if we consider v dash was infinitesimal, then it means that the normal should increase, right, to attain some value. What I'm saying, oh no, sorry. In this way we can see that the velocity and normal are inversely proportional. So at some point they will give the so for some point, like their graph would be like this. Velocity versus normal graph would be something like this, right? Parabola type conditions. So here, somewhere here, the velocity at this velocity, or I can make a much better graph. For some velocity, normal would be 0 here at this point. So we have to find that velocity. What would be that velocity? For theta equal to alpha degree, right? We have to make normal equal to 0 at point C. So that means we have to make theta equal to alpha. So we have to find that velocity. What would be that velocity? So it is simple now. What we have to do? We have to, first of all, we have to put, let's assume the critical velocity as v, simply v, instead of v dash, I am assuming it as v square mv square equal to mg cos alpha minus normal and normal would be 0, right? We have to put normal equal to 0 and it will, so what will it give? V square is equal to gr cos alpha. This is our first equation. So what would be the next equation? Now how to find the next equation? So it is very simple, like it is very obvious. We will be using work energy theorem. We will be conserving the energy. We will be equating the work done by each and every force with the change in its kinetic energy. Okay, so its center was here. It has come here at point C. Its velocity was v naught initially, and its current velocity is v, parallel to inclined. Right. What would be its initial kinetic energy? So it can be found by seeing that it is performing it was always performing a pure circular motion. If we see about this point, when it was performing a pure rolling, then it was performing simultaneously performing a perfect circular motion about this point at any instance. That is the point, the lowest point in the cylinder. It is always performing a circular motion about that point. So we can calculate the moment of inertia of the cylinder about this point. It would be equal to mr square by 2 plus mr square. So it is equal to 3 mr square by 2. Okay, so its change in kinetic energy would be equal to 1 by 2 I omega square omega naught square minus omega square, omega square minus omega naught square. Okay, so it would be equal to 1 by 2 3 by 2 mr square v square minus v naught square by r square. Yeah, I think it is correct, I guess. Yeah, 3 by 4 m into v square minus v naught square. Okay, changing kinetic energy is this, and what would be the work done? First of all, what are the forces acting on this during this motion from here to here? What are the forces acting on it? So first one is obvious, it is gravitational force, it is always there, right? The second one would be friction, and it would be, obviously it won't be doing any work because it is acting at a point which is not moving, so its work done would be always 0 in this time frame. The only work done here is by gravity. So gravity was like at any point the cylinder was in this position, so gravity was acting like this, and friction is acting in this direction, parallel to this and parallel to mg sin theta. Theta was this. Okay, parallel to mg sin theta, it would be always like this. And yeah, so what would the work done by gravity in this process? So to calculate the work done, we can see the change in position of the center of mass, right? Work done by gravity. So this position was B, this position is C, and this point is A, and what we are given is, I guess, this angle was alpha, right? Yes, this angle is alpha. So this angle is alpha, and so what we can infer from this is that we have to just find out the change in height of these 2 points. So this was initially at r height, and this is at what we can say is this angle is, what is this angle? This angle is yeah, this is also alpha, right? This is also alpha. So what would be this height? R cos alpha. So change in height. What is the change in height? Delta H equal to R minus R cos alpha. Right. So work done by gravity would be equal to positive, and it would be equal to mg into R minus R cos alpha. And finally it would be equal to the change in kinetic energy, that is 3 by 4 m into v square minus v naught square. And also put what we have calculated, v square equal to gr cos alpha, and put v square equal to gr cos alpha in this equation. You will get something, I will derive it. Okay, I will derive it. Mass cancelled. Okay, and put v square equal to gr cos alpha here. First of all, let's cross multiply. Yeah, we will be cross multiplying 4 by 3 gr minus 4 by 3. Minus v naught square. So v naught square is equal to 7 r cos alpha by 3 minus 4 by 3 gr, right? So it can be written as, so v naught is equal to we naught are here. Yeah, so v naught would be equal to gr. Oh, wait a minute, what I have done? Yeah, here it is gr. So it also is gr, and we can take gr common. Gr by 3 is common, and the answer would be 7 cos alpha minus 4. So this is the answer, right? So I have covered all the topics about this on this question, and I hope that you would be able to do any such question on the related topic. So let's meet in some other question. Let's meet solving some other question, and have a great day ahead. Bye.